How can you identify parallel lines? Imagine you're looking at two lines on a graph and wondering if they will ever meet no matter how far they extend. It might seem tricky at first, but there are clear signs to spot parallel lines. Let's explore how you can tell if two lines are parallel using simple ideas from algebra and geometry. First, think about the slope of the lines. If you have the equations of the lines in slope-intercept form, which is y equals m times x plus b, then the m stands for the slope. For two lines to be parallel, their slopes must be exactly the same. So if one line has a slope of 2, the other must also have a slope of 2. The only difference can be in the y-intercept, which is the b in the equation. This means the lines rise and run at the same rate but start at different points on the y-axis. Next, consider the distance between the lines. Parallel lines stay the same distance apart everywhere. They never get closer or farther away, no matter how far you extend them. If you could measure the gap between the lines at different points and find it stays constant, then you are looking at parallel lines. Another way to check is by using a transversal, which is a third line crossing both lines. When a transversal cuts through two lines, it creates special angles. If the lines are parallel, certain pairs of these angles will always be equal. For example, the angles called corresponding angles will match, and so will the alternate interior angles. Also, the consecutive interior angles on the same side of the transversal will add up to 180 degrees. If these angle relationships hold true, then the lines are parallel. In diagrams, you might see the lines marked with arrow symbols or the notation double vertical bars to show they are parallel. This is a quick visual cue. When graphing, if the slopes are the same, you can confidently say the lines are parallel. So, to identify parallel lines, look at their slopes in algebraic equations, check if the distance between them stays constant, and observe the angles formed when a transversal crosses them. These clues help you see the pattern and confirm whether two lines will never meet, no matter how far they go.